Uh, so Pivotal Cloud Cache, right? So this is the agenda I have. I think we actually compared to Redis, right? So that's what I have in the agenda. So with that, let me quickly jump to PCC itself. So what is Pivotal Cloud Cache? So Pivotal Cloud Cache, let me get a pointer. So Pivotal Cloud Cache, it's a high performance, high availability caching layer for Pivotal Cloud Foundry, right? For PCF apps, it's a distributed in-memory caching service optimized for PCF apps. It is a key value store similar to the Redis caching solution. So it's a key value store. So it is based on Gemfire. So if you know Gemfire, and so our open source version of Gemfire is Apache Geode. So Pivotal Cloud Cache is based on Gemfire. So all of the code is exactly the same. But this is Pivotal Cloud Cache is available from the PCF marketplace as a tile that you can actually put, and you can access it through PCF. So that's the key difference. So that's PCC. Uh, so essentially, right? So some of the what else does PCC does? So it is horizontally and linearly scalable, which means that you can add nodes to the cluster. So to expand memory, so you just add nodes to the cluster. It's elastic. So what that means is that it dynamically rebalances partitions as nodes are added or removed. And then PCC is fault tolerant. So there is no single point of failure. So there are built-in data replication mechanisms that protects you against node failure as well as cluster failures, uh, as well as a failure of an entire availability zone, or even the failure of an entire site, right? So it's highly tolerant. So there is no single point of failure with PCC. And then it also has this Spring support, right? So there is extensive support for Pivotal Cloud Cache as a caching provider in the Spring framework. So a Spring developer, he can very easily and very fast set up, right? So he can easily quickly set up a cache directly from their application code. So that is essentially what PCC is. It's a caching solution. Uh, so how does it actually fit in, right? So this is the current state, right? So if you're looking at a monolithic application, so this is the current state of a typical PCF customer. So customers, what they do, they have replatformed their monolithic applications and modernized their applications by decomposing them into microservices, right? So there has been pretty good impressive outcomes with this approach. So you can easily, very quickly move apps over to the platform. However, if you look at it, right, the data has been a bit more stickiness, right? So with large monolithic legacy data source, it was very disruptive. And in any enterprise solutions these days, I mean, most of the time the legacy data stores are left there. So because the tendency is that like it's very hard. It is difficult to decompose them, some of the legacy data. So it's hard to make changes to it. So that's where legacy data still sits. So the solution here is that this Pivotal Cloud Cache. So as you can see, this microservices, right? Instead of database, now you can see this is the logo of PCC. So instead of those databases, right? So now the Cloud Cache acts as a face or the serving layer for many of the microservices. So what you do is so the PCC acts as a serving layer, and the advantage of this approach is that now PCC, the Pivotal Cloud Cache, inherits all of the benefits that you normally see of a platform managed service, such as PAS, right? So you get to have the same benefits with PCC. As we go deeper into when I show you the demo and how this actually use cases when I talk about them, you will understand more how does this PCC acts as a face to the for your legacy data. So besides that, right? So this is essentially what PCC is, and what else does it bring? So let's look at this. So what does a value bring to a customer? So every microservice needs a cache, and here is why. So it provides that isolation that I talked about from your shared backend database. You can think of a cache as a materialized view. For those of you who are not from a database background, so a materialized view in the database world is nothing but a database object. So typically when you query a database, right? So whether you are querying a table or a view, whatever the results of that query, you normally put that in a materialized view. So the results stay inside of a materialized view. So you can think of a cache, this total cloud cache, as a materialized view of your backend database. Okay, so that's isolation, right? So that's one benefit, and high availability, right? So again, we have so from the data perspective as well as from the microservice perspective, if you keep all your services in an external cache, and if the platform manages it, right? So you are looking at your session data having a much more so you can think of it as if like uh, you are stateless while presenting a rich stateful user experience. And I will explain this when I talk about when I do a demo on session state caching, how you do that. So even if your application service goes down, your caching your session data still stays in the when you externalize it to a PCC cluster. So this high availability is another benefit. And performance, right? So performance is something that like almost anytime you hit a database, it is always slower than when you hit a cache. So if your applications are using cache, they will perform better. So that's another benefit. And then load balancing. So typically, if you're in a legacy JTE application, like if you're running it on a WebLogic or WebSphere kind of application server, right? The way you maintain session data is you maintain it through sticky sessions. So the Java developer handles that sticky session data. But then if you externalize this session data to a cache, you don't have to worry about the sticky sessions any longer. So all of the instances, right, all of the service instances will have access to the same cache data. So that's another benefit of using a cache. And then this horizontal scalability, right? So microservices and data cache can scale independently. So you can scale your PCC cluster, and at the same time, you can also scale your microservices independent of each other. So that's another benefit of using the cloud cache. So any questions so far before I go to some of the usage patterns?
Do you think that the load, if you go back to that load balancing around the no need for sticky sessions, I feel like sticky sessions are a common thing.
Mm-hmm.
Is it relatively easy to swap out that usage in standard Spring, or even if we're moving?
Exactly. And
yeah, this is like a quick win, right?
Exactly, very quick win. And it's so easy that like the developer doesn't have to actually change any of the code. So when I actually go to the demo, I will show you in the code. All they have to do is in the configuration say that that Spring Boot application bind to this PCC cluster, and that's it. So I will actually demo that instead of using sticky sessions, how you can actually externalize that session data to a cache. So this is a very quick win here.
Hey, Tej.
Yeah.
Hey, I had a quick question as I was hearing, and I joined a little late. But one of the things that I was hearing on the slide, or maybe even on the previous slide, the way you were explaining the microservices to a database dependency, was that the PCC kind of acts as an intermediary of sorts. Now, in ages past, we had used object relational mapping and things like that, not quite the same as a cache. Are we saying that in a typical application context that I can persist my data that I'm dealing with as objects through the cache, and the cache serves the purpose of, like, for example, a Spring persistence layer and things like that? Is that
yeah? So if you what I will do actually to answer that question, I have a usage pattern that exactly talks to what you were talking about. So this is a strong consistency, right? So first you write to the cache, and cache does it synchronously or asynchronously to the database. So that's a use case usage pattern that the banking and in the trading industry they use for that exact purpose. And
Okay.
I have a usage pattern. I'll discuss more in the subsequent slides.
Okay. Yeah, that'll be helpful.
Sure.
Pete, I had a couple of questions. They were mostly coming from the ops angle. So if you're going to cover the deployment topology of how you install and configure PCC later in a subsequent slide, then I'll just hold off on my question.
Yeah, if you can hold off, Prasad, I have actually, I'll show you how I installed it and how
Sounds
to
good.
configure. Okay.
Thank you.
Cool. So some of the usage patterns, right? So when I actually talk about this usage pattern, so these are the some of the patterns that we can pitch to the partners and customers, right? So essentially, you can bucket them into this static or slowly changing data HTTP. So I'll go through each one of them. I will not read out each right now. So the first one, static or slowly changing data. That's a usage pattern. So any data, static or slowly changing data. What is the use case for this? So any data that does not change often and can be pre-computed and is read frequently and is read frequently is a great candidate for caching. So what does that mean? So one example is that any website that you go, right? So the opening page of a website consists of normally dozens of calls to several databases, right? In order to get that data needed for that display. So much of that data is, I mean, relatively static. I mean, it doesn't change. And you can actually compute that maybe overnight. I mean, in the insurance world, what they do is they do pretty much everything overnight. And if you can store that cache, the display, right? If it's coming from the cache, I mean, the web page renders faster as well. So that's one use case. And in the health insurance, right? In the health insurance world, pretty much everything they do is computed overnight, whether it is policies or procedures or providers or coverage data. So all of that, what you can do is you can actually cache it. And only the active claims that need to be, I mean, if you have to access it, that can go to the system of record. That could be a database, right? So all of that so that's a great candidate for caching. Also, so let's say a copay, right? So when you're looking for a copay for a procedure, that hits multiple database tables, but nearly all of that data is usually static. I mean, it does not change very often. And that's, again, a great candidate for caching. And this is exactly the use case that one of our customers, so HCSC, right? So HCSC is a PCF customer, and they use Pivotal Cloud Cache for this exact very use case. So the HCSC uses this, like when you log into their website, the copays and all, that's all cached, and it's coming from PCC. So that's one use case. Another use case is this HTTP session data. So this is what Colin mentioned, right? So whenever we log into any website, right? So what happens is that as you click around a website, whether it tracks where you have been, what you have looked at, where on the site you have navigated. All of that information is called static data. So what happens is typically in a regular world, what normally they do is they keep that session data in the application server itself through sticky sessions. So what if you can actually externalize that, right? So instead of that session data, instead of keeping it on the app server, if you can put it in a cloud cluster, PCC cluster, so even if your application server goes down, application server 2 can pick up that session because it's externalized. And in fact, this is actually a key construct of your cloud native applications, right? It's one of the 12 factors. One of the 12 factors is that like you have to externalize your session data. So that's an use case, right? So make your app server session cache fault tolerant scalable. So this PCC runs in multiple availability zones, and like all your session data is always available. So this is another use case that is very important, and I think PCC is a great fit for that. Next up is this application data beyond current login session. So what happens, right? So this is, I mean, examples are shopping carts, preferences, recently viewed items. So any e-commerce website, right? So this is, again, we see day in and day out, right? Like you go to a website, what you do is you're trying to buy something, you add some stuff to your cart. So you decide that you don't want to buy it, and then you log off. So your session has ended. So your session data has ended. But you come back 10 days later and you go to that website, right? Whatever the e-commerce website, your shopping cart is still there, whatever you have added. So essentially what they are doing is that they are putting that shopping cart in the cache so that you can come back and then you can finish it. So that again adds this user experience, right? So that's what you can actually do. So that's another usage pattern for PCC. So another, this is what Shankar talked about, right? So Shankar was saying, so the use cases, update heavy apps cannot operate correctly without strong consistency. So the use cases are like banking, insurance, logistics, online trading. So all of these are use cases for strong consistency. So here, they are doing what they call it as inline caching pattern. So you normally do like first write it to the cache, and then synchronously write it to the database. So again, I mean, that's the use case. Maybe I can give more information later, but so in the interest of time, I will go to the next one. Next one is this PubSub pattern, right? So PubSub pattern is for topic and content-based PubSub. When you're integrating apps on platform, right? It can be done easily using PCC so that you can actually build this event-driven apps. So that's another use case. Together with Apache Kafka and PCC, I think this is the best solution for that. Another pattern is this multi-foundation, multi-site. So this is again, there are three reasons why you might consider multi-foundation, multi-site. So the first reason is that in a disaster recovery scenario, especially in the financial industry, right? So they have a mandatory requirement that they always keep a second copy of the data at least 100 miles away from the primary, right? So in disaster recovery scenarios, having this WAN replication, right, between different sites. Maybe you have one site in New York and another in California, and if you have this caching replication, WAN replication, right, so that you have disaster recovery is a scenario where you can use PCC. And another reason for you to have this multi-site solution with PCC is because for cloud bursting, right? So you might actually have your application on-prem, and if you anticipate a seasonal peak workloads, like maybe Christmas time, right? So you want to augment your capacity and move to the cloud. You can use this WAN replication, WAN gateway to do that. And the third case would be that global access, right? So if you have customers around the world, what you will normally have is to have a much more responsive system. If you can actually process their requests local, right, to where they originate, that would be a better solution and better user experience. So that's another use case for PCC here. So, and finally, server-side functions. So here, I mean, this is another success story, right? So MasterCard is an existing customer of ours, and they use Pivotal Cloud Cache for this credit card fraud detection. So what this is saying is that applications like credit card fraud detection or trader risk management, right? They are best implemented if you can push the code implementing that functionality closer to the data itself. So MasterCard is a use case, right? So they use that for this very purpose.
So I'm interested in the multi-site use case. Is that, I mean, how resilient it is, or how it responds to? Can you do like synchronous replication, and what distances is like we have seen in production? Maybe is my question, and whether we can do zero data loss kind of use cases.
Yeah, zero data loss is a use case. Yeah, that's exactly. So when I compare it, our PCC to Redis, that's exactly the point I was going to say. That Redis actually cannot guarantee 100% zero data loss, whereas PCC guarantees that because of this WAN replication.
And is that over 100 miles distances?
The distances, again, I have to actually look at the documentation. We will check that.
Okay.
I'll follow up on that.
All right. Thank you.
Okay.
Yeah, I mean, Ford was using, my understanding is Ford was using Gemfire, so not PCC specifically, but the WAN replication across East US, West US, and China.
Yeah.
Wow. Okay. I mean, that's a very good selling point.
Yeah.
Yeah. Okay. Thank you.
Cool. Any questions on that before I go to the architecture? Okay. Let's go to the architecture, right? So very quickly, so how does PCC look like, right? So when I create it, so when I do the demo, I'll show you how to install it. But when I create a PCC cluster, right? So there are essential components. Two components are there. So one is this locator. A locator. So there is a locator, and then there is a cache server. So when I create a PCC cluster, there are minimum of 3 locators and a minimum of 4 cache servers. Okay, so essentially how they communicate, right? So this is how they communicate. So let's say I'm a client, right? So and when it first connects to the cluster, right? So first what the client does is it connects to the locator. And then locator, what it does is it replies with the IP address of the caching server so that the client can talk to. Then once that is established, the client directly talks to the caching server. So when the client wants to read or write data, it directly requests directly with the server itself. So what's the value of the key, and then it responds back with the value. If for some reason that server 1 does not have that information, right, then server 1 sends it to the server 2, and if it has the value, it will come back. So that's how they communicate. So essentially, PCC, when you create a cluster, you have 3 locators and 4 cache servers. So so this is what it is, right? So locator is providing you this cluster discovery and configuration, and then it is doing this load balancing for servers. Whereas a cache server, it is actually storing this data regions. So what is a region, right? So that's what I'm going to talk next. A region, right? So
Tej, one second. So
yeah.
if you go back to the previous slide, the
Okay.
locator is doing the discovery of the caching servers, right?
Yeah.
And then when a request is coming in from a client,
Mm-hmm.
the actual request to fetch the data from the caching server, is that going through the locator, or is that directly happening?
So first interaction, right? So the very first time that a client approaches the PCC cluster, the locator determines, okay, this client can go to this server. So it could be server 1, server 2, server 3, server 4, depending on how many servers you have extended, right? So as I said, minimum you get 4 cache servers, but you can extend that cache servers to maybe 10, 20, whatever. But there are always, in a cluster, only 3 locators. You cannot go beyond 3 locators, but the cache servers can be more than 4. Okay, so once the client, so the locator tells you which server to go to, and once the client knows which it was assigned a particular server, the communication happens directly between that client and that particular server. And if that server does not have the information that it needs, then it will go to the next server and then ask, okay, do you have that value or not? If it has it, then it will respond back.
Okay, understood. So I'm thinking about like a very large cluster. Let's say if there are hundreds of caching servers in a large cluster.
Mm-hmm.
So there is a possibility that, depending on your configuration, that all your caching servers would require public IP addresses then? Unless they so even in your diagram right now,
Yeah.
I understand you could have all your
virtual server, virtual IPs too, maybe Prasad.
Okay.
Probably these are virtual IPs. I have to check. That's how.
Yeah, and plus I think your app servers and your entire all your caching deployment of PCC can also be like inside on a private network also. That's also a way of.
Yeah, actually, one of the requirements when you install, right, it requires a separate network for the cluster itself.
Gotcha. Okay.
So a region, right? So a region is nothing but you can think of it as a table in a database, right? So So you have students as a region, courses as a region, and then you store your key value pairs with unique keys. So that's the architecture itself, and this is a simple command, right? This is showing I started with 5 caching servers, and if I want to increase that, scale it to 6, so that's the command, and it will scale it to 6. And as I said earlier, only 3 locators. You can have any number of caching servers, but only 3 locators. How do you administer the cluster? So there are 2 tools. One is this PCC shell. So this is called gfish. This is exactly the same thing that you get with Gemfire. The same CLI that you use in the Gemfire, you can use it with PCC. So when I do the demo, right, I will show you how to create a region, and I do that using this the PCC shell. So cluster administration service control is done through gfish. And for the monitoring, you have a browser-based Pulse cluster health monitor. So I'll show you in the demo. So you can actually look at the regions and then look at the memory usage and so on. So that's architecture. Any questions before I jump to the demo?
No.
One question, do we have customers running PCC on public clouds?
I have some success stories when I get there. I don't know if it's public cloud or not. So these are the success stories, right? So we'll discuss that.
MasterCard should be.
Yeah, MasterCard, I think. Yeah, MasterCard, Southwest Airlines, Westcorp, HCSC, Discover, Allstate. Okay.
Hey, Tej?
Yes, Shankar.
Is there any limitation or constraints either with respect to a size of a particular object or with respect to a set of dependent objects, in other words, like an object graph that gets populated in this cache?
I don't know. I'll check.
Okay.
Yeah.
And I would assume that you can set up all your caching policy algorithms also, right?
Yeah,
Awesome.
yeah. So I'll show you that.
Okay.
So for the demo, right? So the first demo that I wanted to show you is this look-aside caching. So what this essentially is doing is that I have a Spring Boot application, a pizza order deliveries, like a pizza store, right? So the first time, like what I've done, I already, essentially you need a database and a cache, right? So first, so I have already populated my database. I used MySQL in this case. Actually, the reason why I used MySQL was that, so for this demo, I thought I would use maybe Postgres or Greenplum. But the thing is, they both are not available from the PWS marketplace. Even actually, PCC is not available from a marketplace right now. We are on version PCC 1.8. 1.9 is coming in September. That's when we will have PCC available in the marketplace. So what I have done was I actually, again, I had to stand up the platform itself, right? So I had to install PCF and then configure the MySQL and PCC tiles. So it takes a day to do this. I mean, configuration is always takes time, right? It's not very productive in my opinion, but we have to wait. PWS is coming soon. So essentially, right? So MySQL, I'm using the database where I stored my records. So what this is doing is I already have. Let's look. So I have populated this database with some customer information, so customer IDs, and what have they ordered. So that information is in the database. So essentially what this demo is doing is that, like, first time when I query that user, right? So let's say I want to query whether that user, what is the order about? So that query, so first what it does is it will first look in the cache. And the first time that it looks in the cache, it will say, okay, I don't have this. Then what I have to do is I have to go to the database and get the result and then come back. And the next time I run the same query, right? So now it has written that information to the cache, and then it should return it much faster. So to show that, let's use this this username called Brianna Howell. I have that order. So that's the query that I want to run. So first time if I run this, right? So if I run this, so it was a cache miss. It did not find it in the cache, and then it read from MySQL, and it took 137 milliseconds. Now, if I run the same command, same query again, right? Now it should hit the cache. Now you can see that like now it has hit the cache, so PCC. So it responded back in 10 milliseconds. So 137 milliseconds, 10 milliseconds. I mean, as I said, right? Like anytime you hit the cache, you will almost always get it faster than hitting the database. So that's one use case. So this is called look-aside caching. And the second one, this session state caching, right?
Hey, Tej.
Yeah, Shankar.
Yeah, quick. Maybe I'll wait for my question because they may all be related. Yeah, please go ahead.
Okay. Yeah, so that's one use case. Another one was the one that Colin mentioned, right? Session state caching. How can you do it easily? So this what I'm doing here, right? So this is I have a very simple Hello World application. Where is it? So this is. So I was very. Oh, actually, I have to renew my session. Okay, let me log in. So I was just being lazy. I could have created another org, but I just put it my application on system org. So I have a Hello World application here. So what this application is, right? So it's a very simple application. So let's look at the Hello World. So this is a very so get your greeting here. So if I log here, right? So what is your name? So if I say my name is Tej, and then submit. So all of this information is a session data, right? So this is exactly what session data is all about. So every time, like it's stored in my session data. So if I come back here any number of times, because it's stored in the session data, it will not ask me for that login again. So if I show you the code, right? So if I go to my IntelliJ, so this is the code I have. So this is a greeting message. There is nothing that different that the developer is doing. So all he is doing is saying a hello. If the name is null, then give him that box where you enter the name, and then once you have that information shared in the session data, then respond back. So now what happens is, so I also have another method called cycle container. So now this particular this is running somewhere, right? So if I actually replace, if I bounce this this particular let's say this Hello World application, I only have one instance running. Now if I bounce that instance, right? So this session data will be lost. To simulate that, what I have done is copy that. Is that instead of greeting, I'll call cycle container. That I think let's copy paste. So now I should get a bad request. Now if I go here, right? So if the same greeting, I will get a 503 because the application server has gone down. So that means that my session data has been lost. So that's not something that you want from a user experience, right? So you don't want that. So till it comes back, right? So let's look at. So this should say it's starting, or maybe still running. Okay, it's running. So if I go back, right? So what happens if I go to the greeting? So now that session data has been lost, and then it is asking me to enter the name again. So to fix that, right? So if, instead of saving that session information on the app server, what if I actually put that, externalize that, and put it in a cache? To do that, to save time, I already created a service called PCC, My Session Service. So now if I actually bind that, right? So that particular Hello World application, so I have bound that application to this service. So whenever you bind, you have to restage. So that will take some time. So while that takes time, what I will show you is how do we actually set up this PCC, right? So installation, again, PCF Ops Manager. So all I had to do was import that tile from the network.pivotal.io. A few things, Ops Manager. So there are multiple plans you can actually set up. So, so I have disabled all of the plans. I am only using a small footprint plan. But if I were to enable this one, right? So let's say plan enabled, extra small. So maximum service instances, so maximum servers plus clusters, so default number of servers. As I said, always you will have minimum of 3 servers. And then you get three locator servers. So it is asking VM type for the locator VMs. So you can select that. So pretty much, I mean, depending on the plan that you configure, so if you have multiple plans, then when the developer tries to access, you will get to see all of the plans. So in my case, what I've done is selected a small footprint plan. With this, what it does is it will essentially it will put the locator as well as the caching servers all inside of one VM. So for a demo kind of a purpose, I think this is better. But again, depending on the requirements, you configure this. Any questions on this? Again, I mean, same thing with MySQL, right? So you will have multiple plans. What I have done was I enabled only one plan, a simple DB small plan, and I'm using that VM type. So it's not hard. I mean, it's just that like it takes time to configure the whole thing. I mean, setting up PCF and importing this, it takes about 8 hours. A whole day is gone. Let's now look at. I think it should have come back by now. Yeah, so it's running. So now let's do the same thing, right? So if I go to that greeting message. So this time let's give my daughter's name. Her name is Shreya. So if I do that, right? So so if I do that, like same thing, right? So always that session data is there. Now to replicate that high availability, right? So let me go ahead and cycle container. So this time around, so I got the file gateway, but if I go to this greeting, right, it should still say that, as you can see, this should work, but what is going on? Hello world does not exist. Reposted. Let me open this. Where is the route? Okay. So, I mean, it did come back, but the thing is, I mean, it saved that session information, right? It didn't ask me to log in again, so that information was saved. So all they had to do is, I mean, there was no change in the code itself. All they had to do is this configuration change. All they had to do was bind that application to this Pivotal Cloud Cache service.
Hey, Tej, how does it know what does it need to store in the cache then when you just do a binding?
In this case, I mean the session data, right? So if I look here, right? So
no. What I'm asking is there somewhere anything that you're specifying either via an annotation or something that indicates that this is data that I need to keep it in the cache?
Yeah. So here, so request.set attribute get session dot set. So when I create this let me show you the code. So when I create that cluster, so if you can see here, maybe maximize this. When I create that service itself, that my session service, I'm saying do this T session replication. So for that cluster, when I bind that application, right, that session information is always is going to replicate it in the cache. That's the configuration they have to do. That's all. So application server does not keep the session information. It will give all that session information to the PCC. Okay. When you bind your application, right? So whatever the session information for that particular microservice is going to be saved in the PCC cluster. Okay. All right, next. So that's demo, and very quickly looking at the time, right? So success stories. So I talked about HCSC as a success story, and MasterCard as a success story, right? So there we also have Westcorp. They are using PCC implementation. It took 4 weeks, 2 data SCs. And I think this BNSFL is a logistic company. They are using PCC. So we are seeing a lot of, so when I attended that CNFA session, right? So they are seeing existing Gemfire customers. So most of the successes that the team has been seeing was that Gemfire customers, you do a workshop for them, and then 80% of the customers who have done a workshop on PCC bought the product. So that's what they said in the CNFE session that happened last month. So workshop seems to be working good for this PCC. So Allstate, Discover, SWA, Southwest Airlines. So those are the other success stories. So how does it compare to Redis, right? So Redis is again, an in-memory data grid. So open source also. It's again a key value store. So it does this persistence journal into persistent to disk durability, and then it supports many data types as well as many languages, right? So it is very popular, right? So it's the third most popular NoSQL engine, and also it is the #1 in-memory key value store. So this is our biggest competition out there, Redis. But if you look at from the cluster tutorial itself, right? So this is from their own redis.io cluster tutorial. So the strong consistency use case that I was talking about earlier that you can use for banking and insurance and trading industries, right? So there, if you are looking at strong consistency, they do not actually guarantee that they actually wrote in this document, right? So it says that there is a chance that you can lose writes because of asynchronous replication, and it explains what makes that happen. So what kind of a scenario that happens. So that's a drawback that Redis has for that particular use case, strong consistency. So how do we pitch in? So I mean, Redis provides you all this in-memory data grid, similar stuff, right? So what I was talking about. But we also add, in addition to what Redis provides, all of the above. Plus, we also have the synchronous consistency within the cluster. We give native JSON support. We also have role-based access control. So these are the other benefits that you get with PCC. So essentially, that's all I have. So that's in terms of the product itself. So for internal use, we have a PCC page on Inside Pivotal. There was a field kickoff on PCC session. I also recommend everyone actually watching the CNFE recording for PCC.